You know, every time you tap on your phone, or stream a movie, or book a flight, you're interacting with this world that just feels so seamless. It's almost like magic, right? But underneath all of that, there's this huge, complex structure, built layer by painstaking layer. So in this explainer, we're going to peel back those layers and really see what our digital world is made of.
So that's the big question, isn't it? How does all of this stuff really work? I mean, from the little piece of silicon sitting in your pocket to the AI that's suggesting what you should buy next, what are the fundamental building blocks holding this whole thing together? Well, let's dive in and find out.
And we're going to tackle this through a pretty cool lens, actually. We'll be looking at the work of a computer science student. Yeah, by checking out the core concepts that are being taught right now, we can get a fantastic blueprint for how our modern digital world is built, literally from the ground up.
Okay, so we're starting at the very foundation. Think of that as the engine room. This is the physical hardware, the bedrock that everything else is built on top of.
Just think about it for a second. What's the one thing inside your phone, your laptop, even your car that makes it all possible? There's this one component, this tiny piece of engineering that's like the beating heart of pretty much every piece of modern tech you own. Any ideas?
Yep, it's the microprocessor. Basically, it's an entire computer's brain, the CPU, the central processing unit, shrunk down onto one single tiny chip. It's not an exaggeration to say this one invention is the core engine powering our entire digital age.
And wow, the evolution here has been absolutely breathtaking. You know, each generation you see here didn't just add bigger numbers. It literally unlocked a whole new reality for us. The first gen, that gave us calculators we could hold in our hands. The third one introduced multitasking. That's what lets you run more than one program at a time. Then the fourth gen got fast enough to make graphical interfaces feel smooth. That's why dragging an icon with a mouse is something we don't even think about anymore. And today, we're in the fifth generation with these multi-core beasts that can juggle dozens of complex tasks all at once. Incredible, right?
And believe me, the innovation is not slowing down one bit. Today's trends are all pushing in wild new directions. We're talking specialized processors designed just for AI, super efficient chips that squeeze every last drop out of our phone's battery. And then there's the truly mind-bending potential of quantum computing just over the horizon. So, the engine room is constantly being rebuilt, and it's getting smarter, not just faster.
All right, so we've got the hardware, that powerful brain. But a brain is pretty useless without reliable instructions, right? So let's move up to the next layer, quality control. How do we make sure the software running on that fancy chip actually works?
Well, it all comes down to testing, and this is so important. Testing isn't just about someone clicking around trying to find bugs. No, it's a real engineering discipline. It's a systematic process designed to make sure that software isn't just functional, but that it's also reliable and performs really, really well.
And when we say systematic, we really mean it. There's this whole formal process called the Software Testing Lifecycle, or STLC for short. It starts by figuring out what the software is supposed to do. Then you carefully plan and design the tests, you run them, you report any bugs you find, and then you formally wrap it all up. It's a serious discipline.
Now, this basically happens in two ways. You've got manual testing, which is where a human expert really puts the software through its paces, trying to think like a real user would. And then you have automated testing, where software tools and scripts run thousands of tests over and over again, catching problems with incredible precision. And you really need both to do good quality control.
Okay, so we've got a powerful machine, and we have a solid process to make sure its software is reliable. Now, the next layer up, this is where the real magic starts to happen. This is all about making the machine smart.
You know, the secret to artificial intelligence isn't some kind of digital magic. It's math. And specifically, it's a concept called optimization. To put it simply, optimization is just the process of finding the absolute best solution to a problem from all the possible options. The whole goal is just to make something better, faster, or more efficient.
So you might be asking, how does an AI even know what best means? Well, it's through something called an objective function. Think of this as the goal. You have to tell the machine what it's trying to do. Either minimize something bad, like how many mistakes it makes, or maximize something good, like its accuracy. That function becomes its North Star. And where does it search for this best solution? It's in something called the search space. A great way to picture this is like a huge, sprawling landscape of every single possible answer. The AI's job, using optimization, is to explore this entire landscape and find either the highest mountain peak or the deepest valley, all depending on what its goal is.
And this isn't just some abstract theory either.
Optimization is the engine that drives pretty much every field of AI you can think of. It's what lets a machine actually learn from data. It's how a robot figures out the most efficient way to move. It's how a computer can see what's in an image and how your smart assistant can understand what you're saying.
All right, we've talked about hardware, software quality, and artificial intelligence. I know these can feel like pretty abstract ideas, so let's pull it all together with a real-world example that I think we can all relate to: planning a vacation.
Welcome to the world of e-tourism. This is where all those separate pieces we've been talking about finally click together. You've got massive amounts of data, AI-powered systems recommending things to you, social media feeding into it, and a slick user experience, all of it working together to help you plan that perfect trip.
Think about it. This one simple act of booking a trip shows our whole journey. The AI giving you those personalized recommendations, that was trained on big data. You're accessing it all through a mobile app that had to be thoroughly tested. And hey, pretty soon, you might even visit your hotel in virtual reality before you even book it. From the chip in your phone to the code in the app to the smart algorithm, every single layer is absolutely essential.
So why does any of this matter to you, the traveler? Well, because all this tech creates some huge advantages. It's way more convenient, right? It's often cheaper because you can compare prices in a snap, and it gives you access to a whole world of options right from your living room couch.
But, building this amazing, complex digital world also creates a whole new kind of challenge. Once you've built a brand or a service online, how do you actually protect it? And that brings us to our final layer, the legal stuff, the rules of our new digital world.
Yeah, the internet basically invented a whole new category of problems for protecting a brand. All of a sudden, you have to worry about stuff like who owns what domain name, people selling counterfeit goods online, your logo getting misused on social media, and this other thing called cybersquatting.
And cybersquatting is a perfect example of a problem that could only exist in the digital age. It's basically when someone swoops in and registers a domain name that's super similar to a famous brand. They do it hoping to either sell it back to the real company for a ton of money or to just straight up trick customers. It's a problem that literally couldn't exist before the internet.
And that brings us to our final thought for today. We've gone on this incredible journey, right? All the way from a tiny microprocessor up to the complexities of international law. And every single one of these layers is evolving at a dizzying speed. So the real question we're left with is this: as our technology gets more and more powerful, more complex, how are our laws, our ethics, and our rules going to evolve just to keep up?